Hey everyone and welcome back to Perfusion. I'm Anish and today I'm back with a different type of video. So generally I have taught in this channel about control and network EC part and few topics from analog, but today we'll do questions from switched capacitors. Now who should watch this video? If you are a gate aspirant, then also you should watch this video because in the future I'm hoping they will give good questions from switched capacitors. If you are a placement aspirant, if you are preparing for placement in analog VLSI domain, then obviously you have to watch this video. This is the most important video because this can be asked in OAS, written test and in your interviews as well. And generally students get confused on this switch capacitor. So with this one single video, all your doubts will be cleared. So this will be mainly for series circuit of switch capacitors. For parallel, I will also say how to solve those, but this will be mainly for series. Another quick announcement is that like today, when you are watching this video, today 11th of August, we will start the second AIMT All India mock test 2 for analog VLSI placement. Now this will be helpful for gate aspirants as well. You can check your level of expertise on analog electronics and on Aptitude, right? Both tech and Aptitude will be covered. The duration will be 100 minutes, so you will get the real-time environment of gate exam or your written test in your campus placement, right? So there won't be any registration fees. It will be completely free. Okay, just you have to go log into our website, that is perfusion.in, and then you can easily attempt the test. It will start from 7 p.m. and it will end at 11:59 p.m. Also, we have already done AIMT 1 in the previous week, and for that there was a time window, but the time window has been taken out now, so you can attempt the test series anytime. So you must at least attempt that if you are watching this later on, so at least you can get a good idea where you are in the preparation level of analog electronics and general aptitude. So that was a quick announcement. Also, currently huge amount of discount is running on all our courses for special occasion of Independence Day. So you can visit our website and the code will be shown here. You can apply this code and you can get a huge discount of 22%. Okay, total cost will be of 78%. After this the prices will rise of all our courses, so do avail it now, else later on it will be more expensive for you. Okay, so that was a quick announcement. Also in our channel, completely free network theory has been covered, completely free control systems has been covered, mathematics, linear algebra has been covered completely, calculus is also present currently for free, so 2 chapters are there. But for complete mathematics we have launched engineering mathematics course and aptitude course. You can go and avail that. Analog electronics course is already running. If you are preparing for placements, you can obviously avail the analog electronics VLSI course. So that was about the starting part, about the quick updates, quick important announcements. Now let's start our lecture. So these are the questions. You can pause the video and you can try to solve all this, right? Try to solve all this. You have to find the steady state value of V. If I have a switch which is being closed at t equals 0, what will be the steady state value of V? So this is one of the question. This is C and D. This is E and F. And at the end, right? At the end, I have another question that is according to two different switching periods, right? Two different switches are present, and you have to compute the steady state voltage. That is also a very good question. So let's start with this. So what I will do, first of all, I will assume a few notations. What I will assume notation as is that first things first is that this is 12 volt, right? So how do you write 12 volt? Like this, plus minus. So I will write this as plus. So here, right, I will assume that I have a positive charge, and here I will assume a negative charge. The notation is quite opposite, but I will assume like this only. There is my notation, that is what I will assume. And current flows from higher potential to lower potential, and if some charge is flowing right into this plate, if current is flowing, so it will develop a positive charge here, and if the current is flowing out of the plate, it will develop a negative charge. What do I mean by that? I will explain just in a bit. Okay, so the first method is simple voltage method. What is the voltage method? The voltage method is, as soon as I close the switch, right? As soon as I close the switch, what will happen? This has initial charge of 0, right? This has initial charge of 0, a 12 volt battery. This is how the circuit will look. Circuit will look somewhat like this. This is short circuited, this is short circuited, this is grounded, right? So what is it? If I find the current through the loop, current will be, I will be infinity, 12 by, just hold on a second, I will just check if everything is recording or not. Just 1 second. Yeah. So it will be simply 12 by 0, right? 12 by 0, because there is no resistance, so it will be infinity. So what does this infinity signify? This infinity signifies that a impulse current is flowing, and whenever a impulse current flows, it instantaneously charges the capacitor and instantaneously the voltage changes. So basically what is happening, charge is traveling from here to here. Now if some charge is traveling, right? If some charge is traveling, And due to the travel of charge, so what I will assume is the charge is flowing from this higher potential to lower potential, so from positive to 0. So if charge is flowing like this, what will happen is that it will develop some voltage also, because if let's say delta q charge was flowing, right, delta q charge was flowing, what do you know, q is equals to cv. So if and q is directly proportional to v if c is constant. So if delta q charge is flowing, so it will develop some delta v voltage across the capacitor. And I have told you the intuitive way as well, because the impulse is flowing, what is happening, the voltage is getting developed in the capacitor. So delta q is flowing, so delta v voltage will be developed. Now across this, right, if delta v is voltage is developed across this c, across this also delta v voltage will be developed, but in what direction, that is the important part, right? So charge is flowing like this, and what I said, whenever charge is flowing or current is flowing into this plate, right, it is like generating a positive charge. So this will be plus, and whenever it is leaving the plate, it will be negative. So this is my notation. You can choose other notation, but at the end, right, answer will come out to be same, whatever notation you say choose. Just like KVL and KCL, how you choose the voltage and currents, just like that, this is another notation. So this also will develop V. Why? Because what did I say, Q equals to CV, right? If delta Q charge like if delta V has been developed here and the same charge is flowing, so C is same for this, so this will also develop delta V, but in what direction, that is the more important part. So this will be delta V. Now what you do, you simply apply a simple KVL, right? If you apply KVL in this total loop, what will happen, this will be plus delta V, okay, I'm starting from here, ground to ground KVL, plus delta V minus 12 plus delta V equals to 0. So 2 delta V will be equals to 12. So delta V will be equals to 6. Now what is my V? Like delta V voltage has been developed here. So what is my V? V is simply this delta V, right? V is simply this delta V, or you can compute from here as well. I will compute from here as well. I will show you, right? So delta V is 6, which is equals to my V. So if I, now what is the potential here? This has also been charged to what? This has also been charged to 6, right? So if I measure the potential from here, what is the potential? It is V equals to 12 minus 6, which is 6 again. So you can see I'm getting 6 from both ends, right? So we can do the sanity check as well, whether we are doing it correctly or not. Okay, so this is the first method 1. Okay, although sometimes this may feel like unintuitive method, but this is the first method. This I learned from Himanshu. Okay, in his channel he has taught this method. So this is a very good method. We will use another method that is using the same concept, but that is more intuitive. This is a bit counterintuitive, right? So what is the method 2? Method 2 is basic physics, right? Basic physics. This I like one of my good friends at my office taught me. So this is basic physics, right? So there is another method, but that also uses this only. That's just the extension of this. We will learn only these two methods. Basic physics, what do I mean? So here, right, if I just copy and paste this circuit over and again, and at t equals to 0 I close this, right? T equals to 0 I close this. I told you, right, a charge is flowing. Let's say that charge is x. So x charge is flowing. So one thing to understand in this basic physics, right, battery and ground can take in and take out any amount of charge. I don't care about that, but like whatever the charge that is coming in capacitor, I have to keep in check. What do I mean by keep in check? So let's say this battery gives out x amount of charge. So this gives out x amount of charge. So charge is incoming to this capacitor plate. So this will be plus x, right? This will be plus x, right? Whenever it is incoming in the plate, it will be plus x. Whenever it is exiting, it will be minus x. Now one important thing to note here is the total charge across the capacitor, right? Total charge across the capacitor should be 0. That is what we are taught in physics, right? So if this plate has plus x of charge, this plate will have minus x of charge, if you remember it correctly. So total charge should be 0. And again, this plus x is flowing through this whole loop. So again, it is incoming in this plate and it is exiting in this plate. So this will develop plus x and minus x. Now what you need to do, you need to simply apply the voltage here. So what is the voltage here after t equal to 0 plus? I can write V equals, so what is basically charge is what? CV, right? Charge is CV. So if it has developed x amount of charge, so what will be the voltage? Voltage will be x by C. So exactly that is what I will write. So what will be V? I can write like another notation that I will take. This is positive charge, right? So I will always take the first charge of the first plate for computing the voltage. What do I mean? So the V will be equals to plus x by C. That is my convention. So here V will be plus x by C equals to, now here what is the voltage? this again I will take the plus first this plate, right, of this voltage, that is plus 12. So this will be plus 12 and this is what, minus x by c. So you have to take care of the notation. So like, why did I write 12 here? Because this is not charge, right? This is simple voltage, that's why I'm writing this voltage. This is also voltage, but this is charge divided by c, that means this is a voltage, that's why. So what will be my x will be 2x by c equals to 12. So x by c will be equals to 6, this is volts, and exactly that is what I need, right? So my V was equals to x by c itself. V was equals to x by c itself. So x by c equals to 6 volts, that is equals to my V. So V will be 6. We found out from here and here as well. Although this method is more intuitive because you are exactly understanding that x amount of charge is flowing through all of this series circuit, and this is more easier to understand. Why? I will say when we will solve the difficult questions. But generally this method is preferred whenever we are trying to solve in series circuits, and that method is preferred whenever we are trying to solve in like parallel circuits. In combination of both, you can prefer any one of them, right? That's fine. But generally I prefer this method. Now let's solve it for the second question. Second question is pretty simple. Part B is again simple, just the polarities have changed and also the values of capacitors have changed. Now if the values of capacitors has changed, so the voltage developed will also be changed. What do I mean by that? So again, impulse current will flow as this switch is closed. So now what is the direction of the impulse current? Direction of the impulse current will be like this, because it will flow out from this positive terminal of this voltage. So direction of the current will be like this. So it will get charged and it will develop some here voltage delta V and some voltage delta V here. Will this voltage be same? No, they won't be same, right? Because the capacitors are different. Charge is same, but voltage is not same. So if across this a delta V voltage is developed, what will be the voltage across this? Let me name this as delta V2. So I know charge will be same, right? If charge is same, so how much charge has been developed here? It is C times V, that is 3C times delta V should be equals to this charge that has been developed, because same amount of charge is flowing throughout the whole circuit. So this will be 2C times delta V by 2. So not delta V by 2, delta V2. So delta V2 will be 3 by 2 delta V. Okay, so this will be my delta V2. So this is my delta V2. So now I know my delta V2. Now what I can do, I can simply apply the KVL as I told you earlier as well. So I can apply the KVL throughout this whole loop. So I will start from like this minus. So this will be minus 6 plus delta V plus delta. This is delta V2. So delta V2 is simply delta V into 3 by 2 equals to 0. So this will be 3 by 2 and this is this will be 5 delta V by 2 equals to 6. So my delta V will be equals to 12 by 5. And I need to find V. What is V? V is simply equals to delta V minus delta V2, right? If I compute, V is simply equals to minus delta V2. V is equals to minus delta V2, which is equals to minus 3 by 2 into delta V, which is 12 by 5. So this will be 18 by minus 18 by 5, which is minus 3.6. Now you compute with this also, you will find out the same answer again. So like let's do this with the second method. So if I solve this with the second method, what will be the answer? So I will just paste this circuit again. This was the method 1 and this is the method 2, that is the basic physics. So now if I solve this, what will I get? So again, what will I assume? So some x amount of charge, this voltage source is giving out some x amount of charge throughout the circuit. So x plus x amount of charge will develop because this charge is flowing into this plate and this charge is flowing out of this plate. So this will be negative. Again, this charge is flowing into this plate. So this will be plus x and minus x. So now what I can do, I can again simply equate the voltages, right? So if I equate the voltages, what will I get? So this will be my V will be, now I told you, right, my notation would be the charge across the first plate. That is my notation for writing the voltage expression. Minus x by 2c equals to this is minus 6 and plus x by 3c. Now right in this equation, I don't have to take care of the c, like what the values of c are, like is it 2c, 3c, 5c. Here I had to take care of it because first of all I have to compute this delta v2, right? But here this will automatically get sorted. So here my this will become 6 equals to 3x plus 2x by 6c. So X by C equals to 36 by 5. But what do I need? What is the V? V is equals to minus X by 2C, right? So if I multiply minus X by 2C, that will be equals to V. So this will be minus 18 by 5. That is exactly what we got in the previous method. Okay. So now the questions will become a bit trickier. So here in this case, right, in the C case, the capacitor has some initial voltage. So how do we solve this? So what you can do is, I will take this. Sometimes this is a bit counterintuitive if we solve this with the method 1. I will explain why. So in the C, again, I am closing the switch. Now this capacitor, right, has a initial voltage of plus 12. This capacitor has initial voltage of plus 12. So obviously this will discharge and impulsive current will flow. But how much will it discharge? How much will it discharge? We have to find out that. Will it be same as this battery? Will it be same as this battery? Will it be same? The short answer is no, it will not be same. Why it will not be same? Because here it battery can flow out infinite amount of charge, but capacitor cannot. Capacitor can only flow out a finite amount of charge. Whatever initial charge it had, from that only it can flow out the charge. So we'll see the conditions here. So for this case, right, if I want to solve this using method 1, the best possible way to understand this is, first of all, I will like take this 12 volts outside of this capacitor. Okay, so I will draw the circuit like this. That this will be my plus minus 12. Okay, just for understanding, this is not actually happening, just for the understanding we are doing this. Okay, so this is C, and now this C has initially 0 charge, and this is C. Okay, yeah, just hold on. This is closed, and this is C. Now due to this battery, right, or you can understand due to this capacitor as well, some delta V charge is developed across everything. So delta V voltage, that is, so again charge is flowing here, so this will develop a plus minus delta V. Charging is flowing here, so this is again C. So this is plus minus delta V, and this is also plus minus delta V, and this is my V, right? So now if I apply a simple KVL here, what will I see? So I will start from this. So plus delta V, then plus delta V, and plus delta V, and minus 12 equals to 0. So 3 delta V equals to 12. So delta V equals to 4 volts. So delta V is 4 volts. So, and what is V? V is equals to simply delta V, right? V is equals to delta V. Now, before doing this step, right, what I will recommend is, whatever you had done, like separated out this 12 volt battery, now you make it together. How do I make it together? So this, right, this overall combination is what? 12 minus delta V, because these are of opposite signs. So this will be 12 minus delta V. And why is it minus delta V? If you want to understand intuitively, basically it is giving out some charge, right? This capacitor is giving out some charge, so obviously it will lose out some delta V, right? It will lose out some potential, but all of this will gain some potential due to this initial charge. So that's why you can understand that intuitively as well. So what you will do is, now you can write this as this. So this will be 12 minus delta V. This is C. This is plus minus delta V, and this is plus minus delta V again. Now if you want to see, like obviously we have computed V is equals to 4 volts itself, but if you want to compute from here as well, this will also be, should give us the right answer, right? So what is 12 minus delta V? Like V is equals to 12 minus 2 delta V, right? 2 delta V. If I want to write the KVL from here, so 12 minus 2 into 8, which is coming out to be, so not 8 into 4, which is coming out to be 4 again, right? So you can understand that yes, I'm getting the same answer over and again. And you can observe that while we had a battery and we have a capacitor with same voltage charge, both results are different. Why? Because capacitor cannot provide obviously infinite charge, it's at a some finite charge, but battery can provide and take in any amount of charge. That's why. Okay, so I hope you got the point. Now like let's solve this with method 2. So in method 2, right, you don't have to, like method 2 is more intuitive and this is a bit counterintuitive. So here, right, in method 2, what is happening? Simply X amount of charge is flowing out, right? x amount of charge is like this capacitor is providing x amount of charge. So this will provide some x amount of charge. So x amount of charge will be here, and I have told you that total charge across two plates of a capacitor should be 0. So this will be minus x. Again, this will be plus x, and this will be minus x. Now one thing you have to remember, initially how much charge did this capacitor have? In this positive, how much charge did this capacitor have? Let's say initially it had q amount of charge. It has q amount of charge. Now this capacitor gave out some charge, right? How much amount of charge this capacitor gave out? X. So I have to subtract x with it, right? I have to subtract x because initially I had q charge, but I had to give out some charge to this capacitor and through this capacitor. So this has q minus x charge now. Now on this plate I have q minus x. How much charge will be here? Total sum will be 0, right? So this will be minus x minus q plus x amount of charge. So this is the simple equation. What is initial charge q? What is the q value? Q is simply 12C, right? CV. Because initially it has 12 volts of charge. Now I can simply, what I can do, I can again write the voltage at this node, equate the voltage. So what is V? V is x by C or equals to Q minus x divided by C minus x divided by C. So this will be equals to 2x, not 2x, sorry, 3x divided by C. And what is Q? Q is 12C. So 12C divided by C is 12 itself. So x by C is 4 itself. Okay, so which is 4 volts, which is equals to my V itself, right? That is my answer simply. Okay, and you can like cross check, both are same again. Okay, so we will solve this D question, or what I can do is D question I can give you as homework, or let's solve everything here, else like some confusion will still remain. So here, right, why do I prefer the second method? You will understand, because I don't have to take care of the values of C's. Here the values of C's are different, right? Capacitors are different values. So again, if I apply method 1, okay, if I apply method 1, what will happen? Now I will do this a bit fast. So this capacitor has lost a delta V amount of voltage. So how will the voltage polarity be? So this has lost voltage, right? So charge is flowing like this. So here, like charge is incoming at this plate. So this will be plus and this will be minus. Plus minus delta V. This has lost delta V. So how much will this lose? So how we can do is, charge is same, right? So Q is equals to delta V, C equals to 2C delta V2. So this will be simply delta V by 2. Delta V by 2. So this will be delta V by 2, and the polarity will be like this, and this will be also delta V by 3. So this is a simple trick that you can understand, that if this is developed delta V amount of voltage, this will develop delta V by 2 and this will develop delta V by 3, just because 2 and 3 are written and this is just 1C, right? That's why. So now you can again apply the KVL. So if I apply the KVL, this will be plus delta V by 3 minus 12 plus delta V plus delta V by 2 equals to 0. Ground to ground KVL. So this will be 11 delta V by 6 equals to 12. So delta V by 6 delta V equals to 72 divided by 11. Okay, that is my delta V. Now that is my delta V. So what is my V? V is equals to simply delta V by 2, right? Delta V by 2. What is it? It is 36 by 11. And you can cross verify by applying KVL here as well. So switch will be closed. I forgot to close the switch. Switch will be closed obviously. Now in the method 2, right, that is more easier because you don't have to do all this, right? Delta V by 2, delta V by 3, that will get automatically sorted. So how will that happen? So here what you can do is, obviously I'm closing the switch and X amount of charge is flowing out of this. So initially it has Q amount of charge and it has given X amount of charge. So this will develop plus X, this will develop minus X, this will be again plus X, this will be minus X, and this will be minus Q plus X. So now again I can write the voltage equation at this node. So my V will be plus X divided by 2C equals to Q minus X. And what is Q? Q is simply 12C again. Q minus X divided by C minus X divided by 3C, because here there is a negative sign over here. That's why. So what is this equals to? So this will be simply 11X divided by 6C equals to Q by C, which is 12 itself. So again X divided by C equals to 72 by 11, and I needed what is the voltage here? The voltage here is X divided by 2C. So it will be X divided by 2C equals to V equals to 36 divided by 11 volts. So this is basically my answer. This is basically my voltage, which I computed earlier as well. So this is pretty easy, right? You don't have to take care of the value of C. Value of C is taken care Okay, sorry, this was the homework question previously. Just hold on, where was I? Yeah, here, right? So like this was just computed in the previous example as well. So now let's go to the next example. If I go to the next example, we are doing it through the E, right? If I doing it for the E, right, there are two voltages. So what I will do is I will take this example and give this as homework, because like this is the tougher one, this is the simpler one. So I'll take the tougher one. So here this time, right, two capacitors are charged. So for two capacitors, do you have to apply superposition? No, you don't have to apply superposition. Without superposition also you can solve this. So how can you solve? So with method 1, if you want to solve, right, with the method 1, if you want to solve, what will happen? Like a charge will flow and voltage will get developed. So here, right, I have to take an assumption, like due to which capacitor actually voltage is getting developed. I will assume the total voltage developed, right, for this capacitor is delta V. Okay, and in which direction? I will assume that charge is flowing from here, because this is larger, right, this is plus 12 and this is 6, this is larger magnitude. So I will assume that charge flows from this capacitor only. So this has larger voltage, that's why. I can be wrong as well, and if I am wrong, that will come out to be negative. Let's see. So this is flowing out the charge. So for this, right, this will develop a delta V amount of potential. So how will it develop? Basically this will reduce from 12 to 12 minus delta V, because this has lost delta V amount of potential due to loss of charge. So how will the polarity look like? So charge is flowing like this. So this, like, charge is incoming here. So this will be plus and this will be minus, and this will be delta V. This will be what? This will be plus, this will be minus, this will be delta V by 2. Why? Because like C to C, the capacitance value has changed. Again, charge is flowing like this. So this will be plus, this will be minus, this will be delta V by 3. So now I can simply apply the KVL. If I apply the KVL from here, it will be plus delta V by 2 plus delta V by 3. And also you have to take care, we have a 6 volts also, right? I cannot forget the 6 volts here as well. So I'm taking the combined effect of this plus 12 and minus 6, combined effect of this, that overall it for this two capacitors overall potential develop is delta V. Okay, that is the combined effect. So we have to take care of this plus 6 as well, because we have a potential here, and this is minus 12 and this is plus delta V. So minus 12 plus delta V equals to 0. So this will be 11 delta V equals to 6. So what will be this value? This will be delta V equals to 36 by 11, right? Delta V is equal to 36 by 11, but I need the value of voltage V here. So what is that? Is delta V by 2. So V is delta V by 2. It is 18 by 11 volts. Okay, so although this may seem a bit counterintuitive, you can do it with the charge method, and charge method is better. Okay, charge method, you can solve it with more intuition. So in charge, right, what I will do, I'll paste this, and switch is getting closed. So if switch is getting closed, what will happen? So again, this, I will assume that this capacitor is, due to this capacitor mainly charge is getting developed. So this capacitor is losing its charge. So initially, let's say it has some Q1 amount of charge, it is losing X charge, and that charge is flowing like this. So charge is incoming here. So this will be plus X and this will be minus X. Again, this will be plus X, like charge is flowing like this. And you have to understand, ground can take in any amount of charge and lose any amount of charge, just like batteries. So this will be plus X and this will be minus X. But you have to understand, this has also initial charge, right? And this is the positive side. So I will assume this is the plus Q2. Okay, this has some initial charge of plus Q2 and some charge is getting added to it. That's why I told you here, because the voltage due to this is getting developed. This is losing some voltage, this is gaining more voltage. Okay, so this will be, again, this will be minus Q2 minus X, and this will be minus Q1 plus X. Why? Because the overall charge through both of these plates should be 0. Overall charge through both of these plates should be 0. So now what you will do? What you will do is, what is Q1? Q1 is simply 12C, right? Q1 is simply 12C and Q2 is simply 6C, because initial voltage and initial capacitance. Sorry, not 6C, it is Q1 is 12C and Q2 is 18C, right? Q2 is 18C, that is basically 6 into 3C. Why am I writing like this? I will explain just in a minute. So now again I will equate the voltages. I'm doing the repeating the same process. So V is equals to X by 2C equals to Q1 minus X by C. This is my I can write this as plus, but here overall this thing is negative, right? I will write this with sign. So this will be minus Q2 minus X divided by 3C. Okay, so V will be equals to x by 2c. X, no, I will not write it. I will find for x. So what is the x? X will be again 11x by 6c will be equals to, what is q1? Q1 is 12c, right? 12c by c is simply 12 plus what is q, like minus q2, right? I have to write minus q2 by 3c. So 3c will get cancelled and only minus 6 will remain. That's why I was writing like this. So we don't have to compute this multiplication as well. They will get cancelled. So overall my x by c will be again equals to 36 by 11 volts, right? And what do I need? I need V. V is equals to x by 2c. So V will be 18 by 11 volts. So I'm getting the same answer. You can see this has developed some charge, like due to this capacitor this is losing out some charge and this is gaining some charge. Like you can understand intuitively exactly what is happening. That's why this is more intuitive than the previous example. So I took the F1, and with that all the examples of this particular questions which capacitors are done. Like you can solve this for homework. And now let's come to the next one. Next one is also very interesting. This is the time domain one. Okay, why did the question go? This is the great question. Just pause the video for end. Okay, and I will solve this in my channel. Okay, I'll solve this in my channel because this video has gone lengthy and I don't want this to go lengthy. I will link the video to my channel and you can go to my channel and watch the video, link the video. Okay, because this is a bit it will take me 10-15 minutes to totally explain you everything. So I hope you understood this and try to solve it by yourself, and let me know in the comments below what will be the answer to this and also the answer to a E question, right? The value of V voltage, okay, for this E1. Try to solve this. So yeah, thank you for watching. I will see you in the next video.